The graph shows the variation of de Broglie wavelength lambda of a particle and its associated momentum P is. So this topic based on de Broglie wavelength. We know the relation between de Broglie wavelength and the linear momentum as lambda is equal to h by p. So from this relation, what the things we have to know? First of all, h is Planck's constant. So I can write it as lambda is inversely proportional to p. As lambda is inversely proportional, whenever we observe inverse relation, the graph will be drawn just rectangular hyperbola. This is the question came in 2022 NEET. In yesterday paper, you got this stuff. So lambda and p, how they are means they are inversely proportional to each other. So wave and p. So I got the shape of the graph is rectangular hyperbola. So this is about de Broglie wavelength and momentum related. Next. See here they're asking us to find what is the gravitational field intensity. If you observe this question, this is also 2022 NEET question. A body of mass 60 grams, they have mentioned mass as 60 grams, 60 into 10 power minus 3 kg. Converted into gram to kg, we know 1 gram is equal to 10 power minus 3 kg and force is equal to 3 Newton. From these two stuff, they are asking us to find gravitational field intensity. We can also write gravitational field intensity as G. G is nothing but F by M. So I can write here 3 by 60 into 10 power minus 3. There is nothing but 1 by 2 into what we can write here onward, or I can write 50 Newton per kg. See here, force SI unit is Newton, mass SI unit is kg, so 50 Newton per kg, and my option is the first option. Previous question, what happened? Here, don't check, this is not a fourth option, but a rectangular hyperbola where we have, this is the third option. Next. Let's go to the next question here. The ratio of distances covered in when the freely falling body in the first, second, and third, and fourth second is the basic kinematic sum. We know that freely falling body means Hn is equal to U plus G by 2 into 2n minus 1. But here is a freely falling, U is 0. So I can write Hn is equal to G by 2 into 2n minus 1. We have the formula as H1 is to H2 is to H3 is equal to, I can write, because I can write Hn is proportional to 2n minus 1. Just check here. I have taken first n value as 1. If I substitute there 2 into 1, 2 minus 1 is 1. Next, if I substitute 2 into 2, 4 minus 1, 3. H3 means 5. Similarly, we can write 1 is to 3 is to 5 is to 7, like that it go on. So my option is number 2. So this is the basic question which came in NEET exam. So 2022 NEET paper. So this is also one conceptual question we can see in that way, and we got the answer as 1 is to 3 is to 5. Next. See here, this is the very simple straight question from electric potential and capacitance. Here what we have from electric potential and capacitance, if you observe, the electric field lines are always directed in the direction of decreasing potential. So how the field, these are the field lines, and if you observe the equipotential surface, the where what happened? Electric field lines are in the direction of always decreasing potential. The potential is going on decreasing in the direction of electric field. If you take one perpendicular line anywhere, there everywhere on that line, potential will be same. Like that, I have taken one surface here. The electric field lines are normal. So everywhere here on equipotential surface, where what happened potential will remain same. This is called as equipotential surface. And electric field lines and equipotential surface they must be perpendicular. So that answer is 90 degree. Answer is 90 degree for this question. It's a very simple basic question in equivalent electric charges and fields. After that, we have electric potential capacitance. If you observe those chapters, this field lines topic we got in electric charges and fields, and equipotential surfaces in electric potential capacitance. There we got this stuff. Next, this one. Even the 10th class in the books also you will be having this type of knowledge. There is nothing but resistance, how it will be affected for conductors and semiconductors. For conductors, resistance is directly proportional to temperature. So temperature increases, resistance is decreases. Temperature increases, resistance also increases. Temperature directly proportional in temperature increases, resistance also increases. For semiconductors, it is exactly opposite. Semiconductors inverse relation. So temperature increases means resistance value of semiconductor decreases. In conductors, with the resistance of the conductors will increase with respect to temperature, but for semiconductors, it will decrease. So my answer is now for first conductors, increase for conductors, but decrease for semiconductor. My answer is second option. So it increases for conductor because here what they told, temperature increase. So increase for conductors. For semiconductors opposite, decrease for semiconductors. That is a given here. I hope you are clear with this question. See this question, they have given a nuclear reaction, sodium, they have mentioned 20 to 11, and here X, some element they have given, E plus. What is E plus? Positron. Positron means plus 1 is 0, need to know. So positron, here what we heard is in previously, E minus means electron, we do not like this, minus 1 is 0. E plus means positron, plus 1 is 0, I can write. So if we observe the balancing the equation, very basic question here. Here what is there? 11. Here what is there? 1. So what happens here to balance the things? Here 1 is there, 11 is there, means I can put it as 10. Here 22 is there, here 0 is there, means I can put it as 22. So here, if you observe the beauty here, the element has mass number 22, atomic number 10. So here where is the option? Mass number, it has to be 22. Atomic number must be 10. Is it clear? So answer is here because you observe here in the what we have mass number for this one we are taking as 0. Atomic number we are taking like a plus 1 for positron. So here atomic number will become now for new element X it is 10 and here 0 means it remains as 22 and my option is second option. I hope you guys are clear. So even chemistry, you know the balancing of equations, what's there in that, you can happily solve. See the energy that will be ideally radiated by 100 kilowatt transmitter. The power they gave it as power, they gave it as 100 kilowatt. I can write kilo as what can I write? Kilo means 10 cube. And time they mentioned as, this is simply K, kilo. And time they mentioned as 1 hour. 1 hour is nothing but 60 minutes, 1 minute has 60 seconds, so that I can write 3,600 seconds. What they are asking us to find, energy they are asking to find. So power is equal to rate of energy, I can write energy is power into time. So my formula is energy is power into time. So from here, just multiply that stuff and check. 100 into 10 cube, that's nothing but 10 power 5. into 3600. E is equal to 36 into 10 power 7 joules. So here, if you observe, the calculations are also very simple. You don't need to do any hard calculations like that. Simple, damn easy, straightforward calculations are given to us. So the paper, you no need to worry about the NEET paper because your target is not the problematic knowledge, your target is your conceptual knowledge. How far you know the concept, they are checking your subjective knowledge. Pay concentration on that. This is one formula what we have. That is speed of light is given as c. Is we know the formula as c is equal to 1 by square root of mu naught epsilon naught. Here mu naught is called permeability of free space. Epsilon naught is called permittivity of free space. Speed of light in what should I write here? C is nothing but speed of light in vacuum. Speed of light in vacuum. So here what should I write next? V is equal to 1 by square root of mu epsilon. So this is nothing but speed of light in medium. Speed of light in medium. Here what is mu? Mu is called permeability of medium. Epsilon is called permittivity of medium. When we are light is traveling in vacuum, this is the formula what we have, and in a medium, this is the formula. So very simple now. I want to divide with V by C. Just I divided with V by C here. What I got, you can just find out. There is nothing but square root of mu naught epsilon naught by mu epsilon. So V is equal to C by, I can also write here, mu by mu naught into, I can write epsilon by epsilon naught. So V is equal to, I can write C by mu r into epsilon r, mu r into epsilon r. I hope you are clear with this one. So my answer is V equal to C by square root of mu r epsilon r, and that is the third option I got for this sum. This is a standard formula. These topics you can also observe in optics as well as in electromagnetic waves. What is V by C? So what is V by C? That means I have one formula called, suppose if I have taken refractive index of medium. Refractive index, 1 minute. Refractive index of medium, if I write here, refractive index of medium, I can write it as N is equal to C by V, and that is nothing but 1 by what we can write here. Simply here what happens, C by V is a refractive index. I got C by V is nothing but square root of, what should I write? Square root of mu r epsilon r. So in future, they may ask like this also. They may ask the refractive index. Refractive index is nothing but ratio of speed of light in vacuum to speed of light in medium. In ray optics, this is a topic what we have. So I hope you are understanding what type of questions we are getting here. Two resistors of resistance 100 ohm and 200 ohm are connected in parallel in an electrical circuit. So they're connected in parallel, they are telling. So parallel, they tell, first thing you have to remember that beautiful point, parallel. So here, what happened? R1 value is equal to 100 ohm. R2 value is equal to 200 ohm. They told they are parallel. And what they want, the ratio of thermal energy developed. Thermal energy formula, I can write.
There are 4 options.
Yes, V square by R into T. When you selected this formula, sir. So why I selected means when they say parallel, I know that potential is C. And they also mentioned given time. Two resistors of resistance 100 ohm, 200 ohm are connected in parallel. So given time is constant, and adding R parallel means potential is same. I can write H is inversely proportional to R. So H is inversely proportional to R, means H1 by H2 is equal to R2 by R1. There's nothing but 200 by 100. There is nothing but H2 1. So it's the first option. I hope you guys are clear how I handle this situation. This is a simple parallel combination, means I have to select this formula for each. Next. So this is also this you can observe. A shell of mass m is initially at rest. So what happened here? Initially one mass is there, m is at rest. It is at rest. This is based on law of conservation of linear momentum. So here it made into three parts. So they told the masses ratio as 2:2:1. 2:2:1, and two which are same mass, that means equal mass, which are having equal mass, they fly along perpendicular. That means one is moving in this direction, other one is moving in this direction. They are both are perpendicular to each other. The lighter one, let me take here 2:2:1. So let me put here mass also 2m, and here mass as m. It's a convenient, because 2:2:1. Let me take the total mass as now what? 5m. Why we selected 5m, sir? We have to select, generally we have a habit of taking m. If I have to take a habit of taking m, then again I have to divide into parts. It will become little one more step complicated. So instead of that, here 2:2:1 means better to take total mass as 5m. Then this will become 2m. This will also become 2m. 2m is there, then both are perpendicular. There's nothing but 90 degree. So these two resultant will be in this direction. The resultant is in this direction. So what will happen here? This is nothing but P1, P2, both are perpendicular. Square root of P1 square plus P2 square. Clearly you can observe there is a law of conservation of linear momentum. Why? Bomb explosion. Shell of mass m is initially at rest, explodes it all. Explosion is the internal force. Internal force does not affect central, does not affect the what happened momentum of the system. Total moment of the system will remain constant. That is law of conservation of linear momentum. Until unless some external force may be acting there, the momentum is not going to change before and after the impacts. So that I can write here, this is the third mass will be moving exactly opposite to that. Why should that must have moved exactly opposite, sir? Because it has to be in equilibrium. Equilibrium is before momentum. Momentum before and after must remain same. Momentum before and after must remain same. So they has to remain same, means obviously before it is 0. After what happened? P1 bar plus P2 bar plus P3 bar is equal to 0. Then that very clearly I can say it is in equilibrium. So P3 bar is equal to minus of P1 bar plus P2 bar. So simply from this information you can find the magnitude is same. P3 is equal to, I can write square root of P1 square plus P2 square. P3 is equal to square root of P1 square plus P2 square. How you know, sir? How you can write the square root of P1 square plus P2 square, sir? Because P1 and P2 are perpendicular. P1 and P2 are perpendicular means happily you can write like that. Then how to solve, sir? Okay, you told that minus sign is there. What happened to minus sign, sir? Minus sign says that P3 is opposite to the resultant square root of P1 square plus P2 square. So square root of P1 square plus P2 square in that direction means P3 will be in opposite direction. That is explained by negative sign. That is explained by negative sign. So now I am taking the next page here. P3 is equal to square root of P1 square plus P2 square. And I have given, they mentioned in the question, if you observe carefully, both are having mutually perpendicular the same speed v. So this one also traveling with the speed v, this one also with the v. And I don't know the speed of the third particle, let me call it as v dash. What they are asking to find? The third particle speed only. Let us check. So here, this one mass I told, third particle as m, speed as v dash. This is 2m, both are having the same mass, 2m. But speed here, what I wrote here is a v. So 2m whole square, 2m whole square. So now obviously what will happen here, m v dash is equal to 2m v, I can write root 2. M1 will be cancelled. V dash is equal to 2 V, and my answer is V dash is equal to 2 V. Let me check. This is option number 2. V dash is equal to 2 V. This is a basic problem. Is an example for law of conservation of linear momentum. We have the bullet and gun problem, bullet moving front and gun moving back. One example we give. One more, one bomb exploded in 2 parts. One more, one bomb exploded in 3 parts. Everything is there in the notes. Next. Let's see one more. This is based on speed of transverse waves. We know very well, this comes under the chapter, there's the oscillations and waves. In NCERT, oscillations and waves in first year. So what happened here, speed of transverse waves is nothing but root over T by linear density. They are taking the same string, so mu is same here. So speed is directly proportional to root over T. So T is tension in the string here. Obviously, it's a very easy sum. V1 by V2 is equal to root over T1 by T2. And they mention the tension on a stretched string is double than the ratio of initial and final speeds. So tension is double, then I can write T1 is T means T2 is I can write as 2P. So they're asking initial and final speed ratio. Simple. It is a T by, I can write as 2T, T cancel and 1 by root 2. And I can take it as a second option. So it's a straightforward, simple sum what we can observe here. Next. So I hope you are clear to here. Let me give one more question. Just give me 1 minute time. I will load the tab and we'll do that. So I hope you are clear to those topics. And one more interesting question is there based on just 1 minute. I'm taking that question. In thermodynamics, one chapter we have the thermodynamics. In thermodynamics, one beautiful topic is there about different types of process. So here we observe the graph between pressure and volume. What I know is isochronic process I heard as. Isochronic process means I heard volume is constant. And I heard isobaric process. Isobaric process is nothing but isobaric process is nothing but pressure is constant. I heard isothermal process. Isothermal process. In isothermal process, what is constant? Temperature is constant. And adiabatic process, it is heat is constant. Adiabatic process, what is constant? Heat is constant. Q is constant. Like that, we have some stuff. And one more hidden information here is, what is the relation between adiabatic curve and isothermal curve? Here, definitely one thing first, let me check what is the fourth one. It's a parallel to volume axis. The fourth line is parallel to volume axis. It's a parallel to volume axis means obviously the y-axis term is constant. What is the y-axis term? Because parallel to x-axis, y-axis term is constant. That means fourth one is pressure is constant. Pressure is constant means I can write it as isobaric process. Isobaric process. And if I observe this one, it's a parallel to y-axis, parallel to pressure axis. That means x-axis term is constant. X-axis term is volume is constant, and I can write this as isochoric process. Isochoric process. Fine. Definitely from 2 on 3, one is isothermal, other one is adiabatic, no doubt. But which is adiabatic, which is isothermal means very simple thing. slope of adiabatic is, adiabatic slope is gamma times the slope of isothermal, So adiabatic slope is gamma times the isothermal slope. From this information, clearly you have to understand, as it is gamma times the that is isothermal slope, which is having more slope. Adiabatic is more slope. So 2 is having more slope, means 2 is adiabatic from the graph, and 3 is having less slope. It is isothermal. In the question, what they are asking us to find? They are asking us to find the curve which represents the adiabatic process. Adiabatic is nothing but 2. So my answer is first option. So this is a topic which is present in our thermodynamics. These are the few problems we discussed. Almost now we covered. How many problems we covered? 13 problems. No, I think 12 problems we covered here. So I hope you are clear with these problems of what we discussed. If you observe from start, the first one is based on which topic data. The first problem I discussed is on de Broglie. It comes in dual nature of radiation matter chapter. Next one is about gravitation and gravitation chapter, about gravitational field intensity. Next one is in motion in straight line, about that is a freely falling body, and this is electric potential capacitance about equipotential surfaces, and this is current electricity connected topic about resistance affected with the temperature. And again, this we got about transmitting power. This year we got energy and power time relations. And after that, we got the speed and flight and speed of flight in vacuum and in medium. Based on that, then we have again current electricity related electrical resistance, heat develop, thermal effects of current. We observe, that means we observe which is inversely proportional to R. Next, here what happened, heating effects of current, that is. Next we observe the law of conservation of linear momentum, and finally again we observe speed of transverse waves and thermodynamics graphs. I hope you are clear with this stuff. Okay, you can rejoin. Thank you all.